Hello everyone, my name is Zhengui Liu. I am an instructor from Nanjing University of Finance and Economics. Today, I'm going to introduce a work, Update Out Yet Track. Are regulations enough to protect user privacy? I did this work when I was a PhD student in Texas A&M University with Dr. Saxena and collaborated with Boomer from Washington University in St. Louis. Privacy issues are a big problem right now. Large companies like Meta, Amazon, and Google are all fined by privacy violations. Privacy issues happen when users browse the websites, when they buy products on e-commerce websites, watch online videos, or read news online. They might be marked by online tracking without notice. Their data might be shared or sold without their consent. So, people may ask, after the user select to opt out, which means rejecting giving consent, if choice is correctly conveyed, if online service fail to comply. There are three contributions in our work. First, created a framework to audit the regulator compliance of online service. Then we conducted audits of online service for compliance with GDPR and CCPA. In the end, we analyze the relationship between regulations and controls offered by advertisers. So in our methodology, there are totally 4 steps. In the first step, we simulating user interest personas. We first use a brand new browser to visit a list of user interest websites. Then we get the updated browser. In the second step, filling opt-out and header bidding supported websites. We first have the Alex top 100K websites. Then we inspect them one by one to check if they support the Prebid.js and the CMP at the same time. If the answer is yes, the website will be counted as a supported website. So after visiting all 100K websites, we have the CMP and Prebid.js supported websites. The third step is called measuring targeting on user interest personas. So we use the update browser from step 1 to visit the supported websites from step 2. Then we do the opt-out or opt-in on the supported websites to collect biz and HTTP data. The fourth step is called reporting and analysis. So in this step, we analyze the data collected from step 3, which are biz and network traffics, to do analysis. So in the first step, user interest personal simulation, we totally have 16 categories. So all categories are from X top websites. In each category, we have 50 websites and the training websites. So we have adult, arts, business, computers, games, health, home, kids, news, recreation, reference, regional, science, shopping, society, and sports as 16 categories. So we use OpenWPM to automatically visit top 50 websites from all 16 different interest categories to simulating 16 personals. So for each personal, we visit 50 websites sequentially. And we only visit the main page of each training website. So on each training website, we move our mouse randomly or scroll up and down to browse the website. So after this step, we have the trained profile in the browser. The second step, supported websites. We should gather the base data from those websites. So those websites should support the header bidding and the CMP, which is content management platform at the same time. So those websites can be called the testing websites. So we selected the PreBGS, one of the header bidding implementation. For the CMPs, we test all the CMPs listed here, from OneTrust to user-centric. We detected the ALEX100K websites to check if any website supported one of them, and just counted the number of websites that supported each of them. Then we selected the 4 most commonly used CMPs, which are OneTrust, Cookiebot, Didomi, and Quantcast. In this table, we list the actual count of websites that use the CMP and use the PreBGS and both under GDPR and CCPA. So in the end, we have the 352 testing websites. In the third step, targeting measurement, we totally do 2 kinds of measurement. The first one is called the server-side data sharing measurement. We use the bees value from pb.js. The second measurement is the client-side data sharing measurement. We have the cookie syncing events from the HTTP data. We compare the opt-in setting and opt-out setting. We'll compare the bees from opt-in versus opt-out, and we compare the cookie syncing events from opt-in versus opt-out. The left image is an example of what the CMP looks like. So in this image, accept all means opt-in and reject all means opt-out. The right image is what the example of what the bees object looks like. So let me give you some examples of how we measure the bees and how we measure the cookie syncing events. So in the example of bees, we have the personal computer, CMP Cookiebot, location California, action after opt-out. We calculate the average of all bees from the advertisers, and the average is 0.37. And the example of cookie syncing events, we listed 2 examples here. The first one is in the current domain, in the current URL, the value 166 appeared. And in the next URL, this value also appeared. So this value is a shared data. Also in the second example, value PID 35912 appeared in the first URL and also appeared in the next URL. So it should be noted that the current URL and next URL are 2 different domains. So we also calculate the number of cookie syncing events from different advertisers. So here we calculate the number of advertisers, the opt-out setting and the opt-in setting, and we just sorted the advertisers based on the number of syncing events, and we picked the top 5, the opt-out and the opt-in. So you can see that even in opt-out settings, there are still a number of cookie syncing events from some advertisers. Then we use these 6 advertisers and we go back to check the bees data and to compare the number of cookies, the number of bees, which is in the right table, and the average bees value, which is in the left table. So you can see that the number of bees data in opt-out and the opt-in are actually different. And sometimes the opt-out even have the higher bees. So there are large difference. So which means, yeah, the data sharing is happening, which means the opt-out did not work. So we just gathered the client-side data sharing computation and the server-side data sharing computation in this table to just display, to make a summary, to display what actually they looks like. So you can see that no matter under GDPR and CCPA, the 2 regulations did not protect the user privacy pretty well. GDPR did better, but yeah, but GDPR did not do well in all server-side and client-side data comparison in all four CMPs. So in our work, we first designed new methodology to measure the privacy compliance, and we measure the privacy issues under GDPR and under CCPA. And advertisers process user data to possibly target them and also share it with the partners both at server and client side. Regulations may not protect users' privacy, and advertisers may be in potential violation of GDPR and CCPA. Thank you.